Morning, guys. How are you today? Today we talk about the new chapter. I believe it's called chapter 8. It talks about indices or exponents. Before we go into the properties of exponential functions, let's first of all talk about some basic rules that we know. When we say 2 to the power 3, that means 2 times 2 times 2, which is an 8. All right? And whenever you have 2 to the power 5 in the denominator, if you take it up, it will be 2 to the power negative 5. And whenever we say 5 to the power 0, or 6 to the power 0, or 8 to the power 0, or anything to the power 0 is always 1. And keep in mind, the square root of 2 means 2 to the power half. The cubic root of x means x to the power 1/3. All right? And if we say a to the power 2 all square root, the fifth root of a squared, this means a squared to the power 1/5, and 2 times 1/5 is 2/5. All right, these are the very, very, very basic things that you should be able to understand and remember from a long time ago. Now, whenever we say 2 to the power x times 2 to the power y, if the bases are the same, then we add the powers. Okay, for example, let's do the opposite. X to the power 3 times x to the power 5, x to the power 8. So what's going on here? Whenever we have the base the same, when we multiply, we add the powers. Same here. 2 times, same as this one, same base. So the power, we add them up. So how about if I say 8 to the power 12 times 8 to the power negative 15? What happens here? Let's add 12 and 15, which is minus 3. Let's put them in simplest form. 1 over 8 power 3. So whenever you are asked to put things in simplest form, that's in simplest form. And by the way, that's not in simplest form. That's in simplest form. All right? This is one of the rules that called addition and multiplication. And another rule also. Whenever we say x to the power 12 divided by x to the power 9, what happens when we divide? If the bases are the same, then we subtract the power, and x to equals 3. All right? How about one more? If I say 5 to the power, about x times 5 divided by 5 to the power y. When we divide, if they have the same base, then we just subtract the powers. Okay? So far so good? So bear in mind these basic things. Okay, guys? Very nice, very nice. Let's look at the third thing. 2 to the power 5 and all to the power 3. What does that mean? Power and power, we multiply them out. So 5 times 3. And then 2 to the power 15. Okay? How about when I say x to the power half, all to the power 8? What is half times 8? It's an x to the power 4. So far so good? So you need to keep this in mind whenever we talk about solving exponential equations. All right? Keep in mind, so we have a few basic rules here. Then we start thinking about the power rule, where you both have indices. Then when we multiply, we add. And when we divide, we subtract the powers. Okay? Let's talk about something hidden. Some rule that we usually make mistakes. Look at that one. 2 to the power of x times 3 to the power of x. That's opposite. Are these the same power? Yes. So what do? 2 times 3 all to the power of x. So it's going to be x 6 to the power of x. Okay? Likewise, some people think it's different. A to the power of x times b to the power of x. Since both are the same, then we multiply the bases. ab to the power of x. So what happens if I give an example like this? 2 to the power 3x times 3 to the power 2x. Can I do anything about it? No. Neither the bases are the same, nor the power are the same. But I can make the power the same. How? Look, if I keep this one like that, and the 3 will take the square, and 2 to the power 3 is an 8, and 3 to the power 2 is 9. Since the powers are the same, now I can multiply the base, and 8 by 9 is 72. I hope I'm not wrong, because multiplication, sometimes I make mistakes in multiplying. Okay, guys? So it's good to remember these basic things. It opens door when you go to solve an equation in a minute. Let's look at that example. How about 20 to the power of x when it's divided by 4 to the power of x? Are the powers the same? Yeah. So we can say 20 divided by 4, all to the power of x, and 20 divided by 4 is 5 to the power of x. Ah, that's beautiful. How about if we have something like that? 3 to the power 3x when it's divided by 3 to the power of x. Or no, I should make it a little bit unusual. 27 to the power of x, and when it's divided by 81 to the power, let's about say 9 to the power of x. Well, that's straightforward. You know why? Because 27, when it's divided by 9, I can do that. Which is what? The answer is 3 to the power of x. But what I actually want is this. 4 to the power 2x, when it's divided by 2 to the power, let's say 3x. That's good. Are the power the same? No. Here they were the same? Yes, I can do. But here, neither the base nor the power are the same. So what I do, I could take this one, take the power with the 4, and I take the 2 with the 3. Now I make the power the same. Yes. So what's next? 4 to the power 2 is 16. 2 to the power 3 is an 8. And guess what? You can now, if you think about it, 16 divided by 8. And what is 16 divided by 8? It's a 2 to the power of x. So what I did here, I made my expression in the simplest form I can. And that's the beautiful thing about indices. Lots of rules, confusing, but practice makes perfect. So let's put a question here. Put in simplest form. Let's have an example. Just get used to it. I can look at your lecture notes. In your lecture notes, there are many examples over there. For example, 27a to the power 7b to the power 6, and that's to be multiplied by 9. Here we have b to the power -3, and there we have a to the power -8. That's an expression. How am I going to simplify that? Let's first of all look at the numbers. This is divided by 9 is 1 divided by 9, 3. Yes, done, finished. Look at the a. And look at the a. These are called similar. What happens when we divide them? We subtract the power. So a, the top minus the bottom. What is 7 minus 8? 15. A to the power 15. Look at the b's. What happens when we multiply them? We add them up. So what is 6 plus of -3? 6 of -3 is a 3. B to the power 3, a to the power 15, and 3. And that's the simplest form you can do whenever you see an expression like that. All right? Let's take one and mix everything together. How about that? For example, if I have like this, what is that? How do you say it in English? This is called the fourth root of what? Let's say we have x, we have y, and we have 16. All right? And x is to the power 12, and y probably is to the power 1/8. Okay, gentlemen? So now I can use one of the rules I knew. What is that? Keep in mind, the fourth root means something that you need to know, which is we already talked about it. All right? the 1/4, this fourth root means 1/4. If you don't know it, you mess up the question. So you can split them because multiplied. So 16 to the power 1/4, x 12 to the power 1/4, and y 1/8 to the power 1/4. Let's simplify each one alone. So what are the four numbers you multiply, get 16? 2 by 2 by 2 by 2 is 16. So the 16th or the fourth root of 16 is a 2. What is 12 times a quarter? Well, it's a 3. Because 12 times a quarter means 12 over 4, which means 3. How about y? 1/8 times 1/4, which means 1 over 32. Well, so what? 1 over 32. And that is in simplest form. So I made expressions so simple that you shouldn't have any problem with that. Just make sure you can go through them again and again. Let's put another example. Number 3. Can I get something from here and there? Yes, we have good example here. I'm looking at the table. That's a good one. Minus 2e to the power 2x. Minus 2e to the power 2x all cubed minus the cubic root, that is read cubic root, or the third root of 8e 18. 8e 18x. Let's try to simplify that. We already had all the rules in our hand. If minus 2 to the power 3, step by step, and then e to the power 2x all, this is a minus, or plus, or multiply. This is the cubic root of 8, which means 1/3, times e to the power 18x to the power 1/3. So now I broke the basics. What's minus to the power 3? Negative 8. What is e to the power 3 to the power 2? 3. You multiply those. So e to the power 6x. Done. Minus. What's cubic root or 8 to the power 1/3? It's a 2 as well. What is 18 times 1/3? 18x times 1/3. 6x. So e to the power 6x. Something fishy here. This is the same, exactly like that. Those variables are the same. It's like you're saying minus 8x minus 2x. What is the total? Minus 10x. Likewise, minus 8 e to the power 6x and minus 2 e to the power 6x. The answer is minus 10 e to the power 6x. If those were not the same, you cannot do that any further. So that's only an example to show you how I think. All right? Okay, guys. Now, I reviewed with you for, it was about 54, whoa, 15 minutes. Lovely. We probably can take more examples of revising things. Let me take one more example from here. 12x over 4 power of x. 12x over 4 to the power of x minus 2 to the power 3 to the power of x times 3 to the power of x. How may I simplify that? You know, when we divide, if the power are the same, take the 12 over 4 alone. And when you multiply for the same power, then multiply them together. 12 divided by 4, lucky us, is the 3 power x. 2 times 3 is a 6. I can't go any further because this is neither multiply nor divide. If it was multiply like that, I know that's what's going to confuse you. If it's going to be multiply, yes, you can do it because 6 times 3 is an 18. And if it was divide, if that was divide, then 3 divided by 6, we all know what is it? It's not a 2, it's a half. Then half the power of x. And for your information, this half means to the power of 1. I could play the game like that. To the power of negative 1 to the power of x. Yes, because I take it up. If I take it up, it's going to be negative. So I could say minus 1 times x is a 2 to the power of negative x. We need this concept when we start talking about exponential function. All right, gentlemen? So, where this will take us? Our second step is if you master what we talk about in here. If, I'm not lying to you. Then, our next step will be solving exponential equations. This is our second step. So our first step was introduce the rules of exponents, of indices, or powers. Some people, they know some people, they don't know some. And that's where people get mixed up. You gotta read your lecture notes first. Make sure you practice. I wrote this much for you. You put more examples of your own. All right, guys? And once you're done with this, the next session will be how to use these to solve equations. There's one basic rule you have to know. And we're going to introduce all of that into equations. Okay, guys? Have a nice day.